Okay, students, if you remember, last time we did some coding. We saw some functions of arrays, especially of your NumPy, and the last function which we saw was broadcast function. Now there are a few more functions which are available, especially for your broadcasting. It's known as broadcast underscore two, TO2. Now it is used uh, to broadcast an array to a new shape or a new dimension, and it returns a read-only view on the original array. The function might also throw an exception. The exception is known as value error exception. If the new shape does not comply with your rules of broadcasting, which we saw in, say, previous, might be to, I think, the previous session or before that, man. Okay, so let us quickly take one small example here. I'll write the code for you and show you how it is done. So I'll import NumPy. Let us create one array of, say, size 4. So A equal to np dot, I'll use arrange here. So it will create 4 numbers for me from 0 to 3, and I'll use reshape function to change the dimension to 1 by 4. Okay, so I'll have only one row with 4 values in it, or 4 columns in it. Okay, let us print this. I'll write original array, and we are going to print this array. I'll just show you the array how it looks. So here we have a 2D array, okay, and it has only a single row. Okay, one row with 4 columns in it. Now, if I want to broadcast this to a new shape, let us say I want to change this to 4 by 4. Okay, so what I can do is I can make use of I can make use of the broadcast underscore 2 function. So I'll give you a print after using broadcast underscore 2 function. Okay, how I can change it. So here I'll just print it. I'm not going to assign it to A again. Please remember, whenever you are not assigning the new dimension to the array back, okay, it won't change my original array. If I use only in the print statement and I give np dot broadcast to, this is my function, to a new shape, and the first parameter is the name of my array, give the comma, and the dimension. Now the dimension which I want is 4 by 4. Okay. Now if I do this and when I print it, here you can see after the broadcasting to function is applied, the same row which had 4 elements have now been extended, or you can say broadcasted, to 4 by 4, and we have additional 3 rows which got added to my array. Now if I print, or let us change in the previous one only. Let us say I change the dimension. Instead of 4 by 4, I change it to 4 by 3. Okay, will it work? Now, as I told you, if the dimensions are not proper and we are not following the broadcasting rules, this will give me a value error. So an exception will occur. Okay, here it is. And it says, you can see this, the name of the exception is value error. And it is mentioning what is required and what we are trying to do. So we are trying to, the original array has the dimension or the shape as 1, 4, and the request is for 4, 3. Okay, so number of columns, this has to be 4. Whereas this number, the first number, instead of 4, if I give this 3, then there's no problem. So here you can see now there's no problem, and I've got 2 more additional rows which got added. Okay, so neither the number of columns, especially this number of columns, matters a lot. If I give a wrong number here, the exception value error will be thrown in this case. Okay. Now there are a few more functions which will help me in changing the dimension or the shape of my array, and especially along the axis. If you remember last time for your 3D array, I showed you how your dimension looks like. Your axis 0, then 1 and 2. There are 3 axes. So if I want to make changes in either it is a 2-dimension or 3-dimension, if I want to make changes across the axes, then I can make use of a function expand underscore dims or dimensions. Okay. So let me keep this as it is. So I'll keep this as 4. And let us create one more array. Now this time I make use of b here and equal to, let's see, np dot. Now this time I want to use the function array and I'll pass some values. So we have 1, 2 and 3, 4. So let's put a comma here. Okay. There are values like this, and let us display this. Okay, and I need not, I'll mark this as comment up here. Okay, this function. So this is my 2D array with 2 rows in it, and each row having 2 columns. Now to expand this across the axis 0, we'll try both of them, axis 0 and axis 1, because it's a 2D array. I won't have axis equal to 2. Okay, so axis 0 and 1 is available in case of 2D array. I can write here y equal to, let us say y equal to np dot expand underscore dims. Okay, this is my function. Inside the round bracket, I pass the array name. Okay, and I can also give the axis. So let us give the axis as equal to 0. Okay. And I'll print the value of y. Okay, I'll also show you the dimension. So along with y, okay, and this is not x, this name of the array is b. Okay, along with the array, I'll also print the shape of the array. So let me put x dot shape or a dot shape, and I'll also display the other one, y dot shape. Okay. Again, I made a mistake. A, B, this is B. And let us run this now. Okay. Now, as you look at the arrays, the first array, that is B, was this one, the default one, 1 and 2. Okay, and we got here 3 and 4, and it is a 2D. Okay, now look at the square brackets which have been added here when we change the dimension. Okay, and because it is 0 here, the first index, 1D has been added here. Okay, so we got the original dimension was, or the shape for B was 2 by 2. Okay, 2 rows and 2 columns. Now we have a 3-dimension which says that there is only one 2 by 2 array. Okay, how you read this? There is only one 2 by 2 array. Now, can I change this here and make this as 1 and check the difference? So let us do this. Okay, now you can see there's a change here, and even the array has changed the way it is displayed. Okay, what it says is now the 2 by 2 array has been changed to a 3-dimensional array, which says that there are 2 1 by 2 array. So there is a 2-dimensional arrays, and each of them has 1 row with 2 columns in it. Okay, so that's why you can see this gap in between, which was not there in the previous print. Okay, when the dimensions were 2 by 2. Okay, so this becomes a 1 by 2 array, and such we have two arrays. Clear? So you can change this dimension. If I come back here and I remove this, okay, and then I change this one. Let us run this. Okay. Now the dimension has an issue here. Line number, the field element must have 2 or 3 tuples. Okay. Let us put a round bracket and then try this out. So here you can see I have removed the square bracket here, and here you can see this is my original array. Okay, and when I apply this, now we got the same answer. Okay, like the previous one. Yeah. Now in this case, I won't be able to make use of 2 here, or if you want, you can just try and check how it works out. One more thing I'll change is, if suppose I want to specify the dimension as well, I want to know the dimension instead of the shape. So let us display the dimension as well. So I'll give print here, and I have the dot ended, okay, which gives me the dimension of my array, and the other one was y dot ended. Okay, so this here it is. The first one is a 2-dimension array, and the second one is your 3-dimension array. That is y. Okay, after specially applying expand underscore dims. Okay, so we saw three function. One, using the broadcasting function, we saw broadcast. We saw the other function broadcast underscore 2, and this is the third one where we have to expand the dimension across the axes. We saw the function expand underscore dims. Now, what if I want to squeeze the or reduce the dimension, remove the dimension, and come back to the original dimension, which after expanding, or might be I want to reduce the dimension. Okay. Now for that, we have a function which is available called squeeze. Okay. This function removes the one-dimensional entry from the shape of the given array. Okay. And it takes 2 parameters. The first parameter is your array name, and the second parameter is your axis, the axis where you want to squeeze it. Okay, so axis can be depending on the dimension, it can be 0, 1, or 2. So let us write a code here. I'll use x now. I'll create an array x equal to, and let us comment this whole thing. Okay. So let us create one array x equal to np dot. Let us use arrange this time, because I have say 9 numbers, and I'll change the dimension using the reshape function, and let us create a 3D array. So 1, 3, 3. Okay, so I have a 3 by 3 array, you can see. Now let us print this and print x. Before this, I'll just clear this one. Okay. Now when I run this, this is my 3-dimension array. You can see this. There are 3 square brackets. So this indicates it's a 3-dimension array. And I have only a single 2 by 2 or 3 by 3 array, 3 rows and 3 columns. Okay. Now what I want to do is I want to remove the dimension. If you want, you can also print the dimension. So like we did in the previous case, we can say x dot. We can print the dimension using the function endin, okay, which will tell me the dimension of x. Okay, so you can see this is a 3-dimension array. This is the original data. Now let us use the function. So I'll just give a print statement first. After using np dot squeeze function. Okay, so let us. Okay, now it's simple. I want to specify the axis. The axis is optional. If I do not specify it, by default, it is going to take axis as 0. Okay, so I can give here y equal to, or y equal to, say, np dot squeeze. So we have squeeze here with this squeeze into bracket the array x. Okay, and the next line, I'll print the value of y. So print the bracket y. Okay. If you want, we will later on print the shape and the dimension as well. Okay. Now you can see this just one square bracket has been removed from previously there were 2 square brackets, which indicated it was 3 dimension. Now to confirm it, we'll display the shape of it. So let us print shape of the arrays. Okay. Both x and y I'll display in the same print statement. So x dot shape, okay, comma, y dot shape. Okay, this should give me the new shapes. Fine. Now look at this one. The previous shape was 1, 3, 3, and after using the squeeze function, it is changed to 3, 3. Now, what if the dimension was, I change this, say 3, 1, 3. So we have 1. Okay. What it is going to remove, whether it's going to remove only the axis 0, or it will check for one-dimensional array or one-dimensional entry in my array and squeeze that or remove that. Okay, actually what is going to happen is it is going to check in this whole dimension. If I have one-dimensional entry in my array, it is going to remove that. Okay, so in a way it is going to squeeze it. So when I run this one, okay, again what happens? So it is going to keep this 3 and this 3, and there's only one entry for one dimension. That's 1 that has been removed. Clear? So it is not always going to take this first axis. It is going to check your array for the one-dimensional entry. From the shape, it is going to remove that one-dimensional entry. Clear? So there are some few functions which are available in NumPy, especially to change the shape of your array, okay, and also for broadcasting. Now let us create another file, and we'll move on to the new topic of, let us say I want to perform some joining of arrays. I want to join 2 arrays. Okay, so for that we have a function called concat or concatenate. If you remember, even in strings, if I want to join 2 strings, I can make use of some functions. Similarly, if I want to join 2 arrays together, okay, I can use the concatenate function and join it. Okay. Now, while joining, again, you can specify the axis at which you want to perform the join. Okay, you want to combine it. Okay. So let us take another example. We'll import NumPy as np. Okay, we'll create an array A equal to np dot array. Okay, let us give a 2D array here. So we have 1, 2. Put a comma. Don't forget this comma after the square brackets. 3, 4. Okay. Now, in this case, we'll keep one more array and then we'll join them together. So let us say I have another array called B, np dot array, and here again, one more thing, please remember the dimension should be proper if I want to perform concatenation. Otherwise, again, it is going to give me an error. So this dimension has to be matching. So this I'll put 5, 6, and 7, 8. 7, comma 8. Okay, so 2D arrays. If you want, you can display this arrays as well. Let me give the print statement. Say joining to array along axis, and remember the axis by default will be 0. So along the axis 0. Now let us put a colon in 0. Okay, and we can put some dashes. Okay, and to print it, I won't assign it to the array. I'll just print it out. So np dot concatenate. So that's my function. And we have a function concatenate. I can take this a comma b. So that's my array. But remember, this array has to be mentioned inside the round brackets again. Okay, otherwise it will take that as a second parameter, which is the axis that I don't want. Okay, so this whole thing will be inside the round bracket. Just one more round bracket. Clear? And now I'll display this. So run this out. Okay. Now you can see these two arrays are there. We had the previous one as 1, 2, and 3, 4. Now it is added 5, 6, and 7, 8. Let's combine the two arrays. Now, what if I want to get it across the columns? I don't want to. So I want this 1, 2, and then 5 and 6 to be on the first row. Okay. So if you want that, what we can do is we can pass another parameter along with the two arrays which I want to combine together or join together. I can give a comma and I can specify the axis. So if I give the axis as equal to 1, okay, and then run it. Now here you can see, because I've mentioned the axis as 1, the default is always 0. Okay, and if I mention 1, what happens? The first row of the second column gets added to the first row of the first column, first array. Okay, and that's why we get 1, 2, 5, 6, and then in the second row I get 3, 4, and 7, 8 gets added here. So the dimension does not change. Now, if you want to pass 0 also, this is the previous by default which we got in the previous one. So in case of 0, which is default value, or you can give 1, depending on how you want the joining to happen. Clear? Now, there are two more functions which are available, or in fact, you can say 3 more functions available, which can also perform joining. But the way it is joined is different. It's known as a stack. And you know, stack means keeping one thing above the other, right? So I can make use of a function called stack to combine or join two arrays together as well. So let us take those functions and check it out. So let us say I have the same arrays. I'm going to make use of the same arrays here, and let me remove this one. So I'll delete this, okay, and I'll remove this. I'll just keep joining two arrays. Okay. Now using the stack function. So I have a function called stack here. I can arrange the two arrays one above the other. Okay. Again, when we pass the array, it will be A, comma, B. Okay. And if you want to specify the axis, we can specify. And the default one is always 0, so I won't give it right now. I'll just run it. So this is my function. I hope the round brackets are proper. No, one more required. And then we run this. Okay. So here you can see this is my 1D here, and one more has been stacked together and it's changed it. So if I now specify, so let's give this as 0. I hope it is right. has to be inside this 0 and this round bracket. Okay. Okay, so you got the same result. Now, if I change this, say, to 1, okay, so what will happen? Along the axis 1, it is going to combine it, like in the previous case also. Here you can see this. Now 1, 2 is coming from here, and we got 5, 6 from the other array together. Right? And this stacking it one above the other. Clear? So this is one function, and there are two varieties of the stack function. Okay. One is your horizontal stacking. So we have a function called H stack, and for vertical stacking we have a V stack. Okay, so let us use those functions and check it out. So instead of specifying the axes, if I mention H stack and V stack, it will perform the same way for horizontal. Let us give the function np.h stack. Here is my function. Okay, and in the round bracket, you have to just now mention the two arrays which we have. So in the round bracket as tuple. Now, why it is saying tuple here? Because if you look at the function, when we pass the parameters, we are passing the arrays in round brackets, and you know that in round brackets, whenever we pass more than one element, it is treated as a tuple. Okay, and that's why we get, when you put this, you get this tup that indicates that I need to pass the arrays in form of tuples, and that's why you can see I have given the round brackets as well. So extra round brackets are there. So A, comma B. Okay, and this round bracket to complete my print function. Okay. Now, if I want, instead of print, I can assign this, and let us not print this and assign it to a new array. So I give C equal to. Okay, so I'll have a new array with both the values of A and B arranged in a stack in C horizontally. Okay, now I'll print it using the print function. I can print the value of C. Okay, let us clear this first. And now when I run this, here you can see my two arrays, and because of horizontal H stack, what is happening? 1, 2, and 5 as 6 has been added here on the same row. Now the vertical one, it will be below this, so I can change this to vertical, and the answer will be like this. Okay, so one below the other. So all this three functions, the variety of stack function. So we have for joining concatenate, it's one function. The other function we saw was the stack function. And the variety of stack we have, horizontal stack, that is H stack. And for vertical, we have V stack available. Okay. Now let us go ahead and check how to split the arrays. So if I have the arrays, now this is, we are combining two arrays. If I want to split the arrays, how do we do it? We'll create another file. Okay, let us import as anything. I'll create an array A using A arrange, and 9 as a parameter. And now this will be a 1D array. We'll see some example of 2D array as well. Now let us say I have a 1D array, and I want to split this array in some, let us say, 3 equal halves. Okay. To do that, we have a function called split. Okay, so before splitting it, I'll print the original array here, and I'll mention the original array. Let us see whether it's. So from 0 to 9, I have, 8, there are 9 values which are created. Let us split this into equal 3 parts. Okay. So if I say B equal to, I'll assign it to B np dot split and split the array A into 3 equal sections or halves. Okay, and here I can give a print after split. Okay, and I can give this dash n and mention D. Okay, so this is A. This. Okay, here after split, you can see this now. This has been converted into 3 arrays here. So 3 equal. So we have 0, 1, 2, and 3, 4, 5, and 6, 7, 8 into 3 equal halves. Okay. Now there's a variety of split function or the parameters. Let us say I want to specify the index positions from where I want to perform the split. Okay. So if I want to do that, I can create. Let us create another one. C equal to np dot split bracket A, comma. Now I want to split at say position index position 4. So I can give in the square bracket I want to split at 4, and I also want to split at say 7. Okay. So there'll be how many arrays? There'll be 3. The first array will have values from 0 to 3. That's the first 4 values. And from the 4th index position till the 7th, it will take another one. Now, when I print this, let us print say new split. Now you can see this new split here. We have the 4 values here. So this was index position 0, 1, 2, 3. From the 4th one, it is created another array. Okay. And from the 7th one, it is created the 3rd array. So it is splitting at the index position 4 and the index position 7. Okay, so it is not, if you want to do it equally, then we have to specify the number here, like this simple number 3. Okay, and if I want to specify the positions, then you can give this position in square brackets. Clear? So these are 2 options under split. Now, like we had in your stack function, your horizontal and vertical. Similarly, we also have horizontal split and vertical split. Okay. For horizontal split, for this, we'll take another array. So I'll create another array x equal to np dot. It will be a 2D array, so I need a 2D array. I'll make use of arrange, and let us create a 16 values from this and use reshape. Okay, and I'll create a 4 by 4. So 4 rows, 4 columns, that will be 16. Okay. Now, if you want, you can print this out. X. One more thing, let us comment all this. Now this is my 4 by 4 array, which is a 2-dimensional array. Now, if I want to split it horizontally into 2 halves, okay, I can do that. Say I will try to print horizontal split colon slash n. And on the next line, let me write, I'll take another variable y equal to np dot h split. H split is the function for horizontal split into round bracket. The name of the array is x, and I want to put divided into 2 halves, 2 equal halves. Let's print the array y. Fine. Now this was before the split. We got a 4 by 4 array, and after horizontal split, it has been divided into two halves. You can see this is my first array here, and my second array starts from here. So this one. And because it was horizontal, so 1, 2, 4, 5, 8, 9, 12, and 13 is a part of the first array. And the second array has 2, 3, 6, 7, 10, 11, 14, and 15 as the values. Okay. Now, if you don't want the horizontal split, you can also go for the vertical split, wherein I'll just copy this whole thing. And we can just make some changes. This will be vertical. Split, and now instead of H, we'll be having V here. And let us change this to Z. And I'll write this. All this. Okay. Now here you can see this. So across the row. So this is my first row, and second row in my first array, and the last two rows are part of the next array. You can see, right? So using H split and V split, you can also decide how to split my array, especially for your 2-dimension. And the simple function split function can be used with your 1D array. Okay. Now going ahead, let us see how to add or remove elements from the array. Okay. Now you might have already seen in the function, if you remember the function resize function, which returns a new array with a specified size. You can also make use of the shape, the reshape function which we have used. There's another function resize. I think we have not seen this function resize before. So if I want to change the dimension of the shape, either I make use of the reshape, or I can also make use of the function called resize. So let us quickly write one code. So import as empty. Let us create array A equal to np dot array of A range. Here I want 6 values. So you can move from 0 to 5. And I'll reshape this. Reshape. I want this to be 2 by, let us say, 3. So we have. Okay. Now what I can do is I can display the shape of the array. If you want it, I can change this here. Dot shape. We saw this function before as well. If I want to know the shape, so here the dimension 2 by 3. So 2 rows. In each row we have 3 columns. Now I can reshape this or resize it using the function resize. So np dot resize. Now there are 2 parameters which need to be passed. The name of the array. So my name of my array is A, and the new shape can be given in the round brackets. Let us make it as 3 by 2. So 3 rows with 2 columns. And here I can just print the value of B. So let us print. Here you can see previously it was 2 rows with 3 columns. Now there are 3 rows